Synonyms can break phrase queries and silently wreck relevance. We'll use synonym graph plus analyze and ship a Python regression harness so changes don't degrade your top queries. You will leave this video able to inspect how synonyms expand, run safe phrase queries, and catch regressions before they hit users. I'm Professor Pi, teaching search and IR with simple Python. Search teams reach for synonyms to make queries forgiving. That makes sense when users type abbreviations or alternate names. But synonyms can also change token positions and destroy phrase matches. The pain shows up as missing exact hits or noisy top results. Success here means synonyms that boost recall without silently losing the right exact matches. At an intuitive level, Synonym Graph is an analyzer tool that preserves token positions when a single input expands into multiple token paths. Think of it as laying parallel token tracks, so a phrase can still align. A mini example: you want NYC subway to match documents with New York subway and still respect the phrase order. We will build small experiments that first show how expansion looks, then create an index with a synonym graph analyzer, then run phrase queries that use that analyzer, then compare results on and off, and finally wrap a tiny regression harness in Python to catch future breaks. This keeps changes safe and auditable before you push them to production. First, let us inspect how the analyzer expands a query. This snippet uses Elasticsearch Analyze to visualize synonym graph expansion for a toy query. We call indices.analyze with the standard tokenizer and an inline synonym graph that equates NYC with New York. The variable A holds the token stream, and tokes collects unique tokens so we can see generated alternatives deterministically. Using a direct analyze debug avoids touching any index settings, so you can test expansion safely. If you add more synonyms, Tox grows and can include multi-term paths that preserve phrase positions. The printed tokens show the actual analyzer output you will get during search time analysis, and that output is the most reliable guide to whether phrase queries will survive your synonym set. Next, we'll write index settings that include a synonym graph analyzer for search. This snippet creates an Elasticsearch index with a dedicated SynSearch analyzer using synonym graph. We define a syns token filter holding stable, equivalent synonyms and plug it into an analyzer that runs lowercase, then the synonym graph. The indices.create call writes these analysis components at index creation time, which is required for custom analyzers. We don't bind the analyzer to any field yet. We'll invoke it explicitly at query time. Adding synonyms here centralizes control and simplifies safe rollouts. Keep synonym lists conservative at first and expand after you validate behavior with the analyzer and tests. Now, let's index a couple of tiny documents and run a phrase query that uses our analyzer. This snippet issues an Elasticsearch match phrase query that uses the SynSearch analyzer so multi-term synonyms don't break phrase matching. We index two simple docs, refresh the index, and build a match phrase query where the query text is analyzed by synonym graph. The variable R2 holds the query definition, and R stores the results from es.search. Because synonym graph preserves token positions, New York subway correctly matches the document containing NYC subway. If you disable synonym graph, phrase paths often collapse and miss exact phrases. Reading the returned hits shows whether the intended document appears at the top, which is what you care about for user-facing relevance. Next, we'll compare results with synonyms enabled versus disabled to see drift. This snippet compares Elasticsearch match results with synonyms on versus off to expose recall drift. We run 2 searches for the same query, but one uses the Syn Search Analyzer and the other forces standard to bypass synonyms. The variables A and B count returned hits from each run. You can tune synonym breadth by pruning ambiguous pairs. Broader synonym sets improve recall, but may inflate false positives. The side-by-side counts reveal whether your changes increase or decrease unintended matches. Look for cases where a previously top-ranked doc drops out, or where many new low-quality matches appear. Finally, we'll build a tiny regression test that flags changes to top results. This snippet builds a tiny Elasticsearch regression harness to catch synonym changes that hurt key queries. We run 2 representative searches using Syn Search and capture the top document IDs. The variables T1 and T2 hold winners and fail sums mismatches against expected IDs. Store these checks as golden cases and expand them as you discover incidents. If you widen synonyms later, a jump in failures signals precision regressions before shipping. Automate the harness to run in CI and log any change so engineers review whether new synonyms helped or harmed critical queries. If you map this toy flow to a real system, use a small held-out set of your most frequent queries as golden cases. Keep the synonym list in source control. Run the analyzer on any candidate synonym pair before you merge. These steps turn an invisible relevance risk into a repeatable validation process. Recap: Synonym graph preserves token positions, so phrase queries keep working. Use it when you need multi-term or equivalent expansions without losing exact matches. Caveat: broader synonym sets improve recall, but can lower precision, so always validate. Next step: expand the regression harness and add more golden queries from your live query logs so you catch incremental damage earlier. If short, practical IR helps, subscribe and watch the IR videos.